Hello, guys. Hope you are doing well. In this recording, I will be talking about an important process in chapter 6, which is all about the hydrolysis. Guys, the hydrolysis, simply we can define that when a water molecule reacts with ion of dissolved salts, we call as the hydrolysis. More specifically, we can say that the uh, ions of weak acid ions of weak acid and weak bases plus H2O. This we call as the hydrolysis because all of the ions that we obtain from the dissolved salts they do not undergo through hydrolysis. Only the ions that we obtain from the weak acid and the weak base. Guys, the ions can be positive and negative. So, in terms of the types of ions, the hydrolysis distribute into two types, the anion and cation hydrolysis. Let us talk about the anion hydrolysis, guys. The anion hydrolysis, the, the ion that undergo through this hydrolysis should be negative. That's why we call as the anion hydrolysis. And the anion of what? An ion from a weak acid. You know that the anion from the weak acid it behaves as a strong conjugate base. So simply we can say that the strong conjugate bases reacts with water to form a basic solution. This becomes a what as the anion hydrolysis. Let us let me provide the example for this. Suppose here we have got the reaction between an acid with water, acid with water. So when the acid reacts with water, HF, weak acid, it produces a strong conjugate base, which is F negative. And the F negative backs to react with H2O, it because of having a great tendency to attract two protons, the H2O is gonna donate the proton to F negative and F negative accept the proton and then will produce the non-ionized acid molecule with increasing the hydroxide concentration. Therefore, the result of anion hydrolysis, what will happen when we have a process of anion hydrolysis? There will be changes on the acidity of the solution. How? Because it increased the hydroxide concentration. We can say that the hydroxide increase with the solution becomes more basic first. Then hydroxide with pH increases, but the hydronium and POH they decrease, and then non-ionized acid molecule increase as well because here it produced the non-ionized acid molecule and the hydroxide as well. That's the result of anion hydrolysis. How about the cation hydrolysis? Cation hydrolysis is the same process which is a reaction of an ion with water, but instead of having a negative ion here, a positive ion is going to react with water. But are all positive ions undergo through cation hydrolysis? No. Only those positive ions which we obtain from the weak bases, molecular weak bases, they undergo through the cation hydrolysis. We mean when a weak base exists, it produces a strong conjugate acid, and that strong conjugate acid undergo through the hydrolysis. Strong conjugate acid. And then the result of this hydrolysis, there will be an acidic salt, and then the solution becomes more acidic. Hydroxide with pH decrease, hydronium with POH increases, and then ionized base molecule increase. The general reactions for both anion and cation hydrolysis are important. Why? Because it was appear in ministry exam. Which of the following represent the anion hydrolysis or cation hydrolysis? Anion hydrolysis simply is an anion reacts with H2O to form a weak acid molecule with the increase in hydroxide. But cation hydrolysis is a positive ion reacts with the H2O to produce hydronium and then base molecule, weak base molecule. Usually it's weak base. An example for the cation hydrolysis, guys, whenever ammonia reacts with H2O, it produces ammonium. Ammonium, because ammonia is weak base, it produces a strong conjugate acid, which is ammonium, and that strong conjugate acid backs to react with water to increase the hydronium concentration and then produce or increase the concentration of the weak base as well. That's simply the definition of the hydrolysis, the types of hydrolysis, and then uh, the summary of both anion and cation hydrolysis are given here. Properties of anion hydrolysis: uh, first, hydroxide and pH increase, hydroxide and pH increase, hydronium and pOH decrease, but there will not be any change on Ka and Kb. They do not change because they change only with what? With temperature. Amount of non-ionized acid here increase. But for the cation hydrolysis, the hydroxide and hydronium decrease, hydroxide and pH, sorry, hydronium with pOH increase, K and Kb stay unchanged, amount of non-ionized base molecule increase. Guys, let us solve the types of questions that will appear in ministerial exams. Usually, there are two types of questions in hydrolysis. The first type of question is when the ions are given, when the ions are given and asking which of the following undergo through hydrolysis or undergo through cation hydrolysis only, anion hydrolysis only, or undergo through both hydrolysis. The salt can be undergo through both hydrolysis. Guys, the ions, whenever the ion provided, there are two groups of ions. The ions that we obtain from weak acid and weak bases, the ions we obtain from strong acid and strong bases. Those ions that we obtain from the weak acid and weak bases, they undergo through hydrolysis. Those ions that we obtain from weak acid and weak base, they undergo through hydrolysis. But the ions from strong acid and strong base, they do not undergo through hydrolysis, not hydrolyze. Okay, let us provide a few examples. For example, F negative undergo through hydrolysis because we obtain from HF. Cn negative, we obtain it from HCN. NH4 positive, we obtain it from NH3. And S negative 2, we obtain from H2S. These ions, they all undergo through hydrolysis because we obtained them from weak acids and weak bases. And when it requires anion or cation hydrolysis, whenever the ion is anion, it undergo through anion hydrolysis. Cation, they undergo through cation hydrolysis. But examples for those that they do not undergo through hydrolysis, for example, Cl negative. It does not undergo through hydrolysis because we obtained this from the HCl. K positive, we obtain from KOH. It does not undergo through hydrolysis. Br negative, HBr. SO4 negative 2, H2SO4. So they do not undergo through hydrolysis because we obtain them from the strong acid and strong bases, guys. About the salts, there will be we have got four types of salts, guys. Let me talk about the types of salts in general. The first type of salt is what is a neutral salt. Neutral, and then acidic, and then basic, and then a type that we obtain from weak acid and weak base can be all acidic, basic, or neutral based on the Ka and Kb values. Guys, whenever the types of the salts are given, we have to determine there are different possibilities. For the neutrals, there is no hydrolysis because we obtain both ions, cations, and anions from the strong acid and strong bases, like NaCl, Na2SO4, Mg, or we can say BaCl2, KNO3, and so on. These are all neutral salts, and then the neutral salt, they do not undergo through hydrolysis because of we obtain both ions from the strong acid and strong bases, guys. How about acidic? Acidic, we obtain the anion from the strong acid, but cation from the weak base, so it undergoes through cation hydrolysis. Example like NH4Br, NH4Cl, and so on. As you can see, guys, here the this we have obtained from HBr and HCl, but these two from NH3. Whenever the strong side is the name of this salt refers to the strong side. It's here is acidic is a strong side, so it becomes acidic salt, and then the strong, the weak, they become a weak conjugate bases, Cl and Br negatives. They do not undergo through hydrolysis. Only the NH4 positive undergo through hydrolysis. That's why it's cation hydrolysis, and you know that the cation hydrolysis it increased the hydronium concentration, reduced the hydroxide concentration. That's why the medium becomes acidic. And then the next one is alkaline. The alkaline or basic salt, it undergoes through anion hydrolysis. The anion hydrolysis, we can say that simply uh, is the opposite of the cation, uh, which the basic salt, the cation, it's from the strong base, and then the anion from the weak acid. For example, Kf. More example, Li2S. If it dissociate, this is insoluble salt, we know that, but if it dissociate to the ions, and then more examples, Ca, uh, CaCO3, calcium carbonate. This is a basic salt as well, and the we can say that these are what the anions we obtain from the weak acids. That's why they undergo through anion hydrolysis, and then the cations we obtain from the strong bases. That's why they do not undergo through hydrolysis. And the basic salt is that's why they undergo through hydrolysis. That's why the solution becomes basic. It increases the hydroxide, decrease the hydronium. And then the last type of the salt is weak acid we obtain from weak acid and weak bases, it undergo through both hydrolysis. Both hydrolysis. Example for this, a simple example is NH4F. NH4 we obtain from the NH3 and then F from HF. Here, whenever the question said which of the following salt undergo through hydrolysis, you have to search for a salt that we obtain from both weak acids and weak bases, their ions. It becomes the salt that undergo through both cation and anion hydrolysis. This type of salt can be basic, acidic, or neutral, depends on the Ka and Kb value. If Ka is equal to Kb, it's neutral. If Ka is higher than the Kb, it's base acidic. If Ka less than Kb is basic. But in all these three cases, it undergoes through both hydrolysis. It won't act as the neutral salts. That's all about the hydrolysis types of questions, guys. Thank you for the attention.